All right, welcome to our very first lesson on this platform, the acid-base titration calculation. So we had previously today looked at this particular acid-base reaction of sodium hydroxide with oxalic acid. We identified that the metal salt that produced was sodium uh, oxalate and water, and as you can see, the equation has been balanced as prior. The concentration of the oxalic acid, 0.01 molar, that was something that is from our standard solution. The question is to calculate the concentration of sodium hydroxide. So the table that you see, these are theoretical results as far as our measurements are for our pipette and our burette. Remember that when it comes to your burette, that is your unknown solution, and when it comes to your pipette, that is your standard solution. So obviously your standard solution, 25 milliliters, which is centimeters cubed. So here is our standard solution, and on top you have your unknown. Now, as you can see, we've done 3 titrations, and we're taking your average. So when calculations are done, we're always doing calculations on a single value. That value comes from your average. So if you're ever given a question where it was a titration acid-base question and they actually give you the results, when it's time to do the calculations, if the average has not been given to you, you calculate the average, and that is the value that you are going to use. So the formula I'm just going to make use of, your number of moles of your acid over your number of moles of your base is equal to your concentration of your acid times the volume of your acid, all over the concentration of your base times the volume of your base. This is a ratio, meaning that in terms of SI units, it's not necessary, because whatever units you use in the numerator and whatever units you use in the denominator, as long as those units are the same, they're going to cancel each other out. So for this particular formula, SI units are not necessary. However, if you're going to use the formula of concentration is number of moles over volume, here you are going to have to convert. So let us identify our variables. I'm just going to go to the second page, create a second page. Right, so now let's identify our variables. In terms of the variables that we do have, we have, so this is step 1 here. What variables do we have? We have the concentration of the acid, 0.01 molar. We have the volume of the acid, which is 25 centimeters cubed. We have the volume of the base. What's the volume of our base here? It is 27.3 centimeters cubed. So let's just go and put that in there. 27.3 centimeters cubed. And we want to calculate the concentration of the base. What is that? Remember that your number of moles for your acid and your number of moles for your base, that comes from your stoichiometric coefficients. So we have a look at our stoichiometric coefficients. This is the number of moles for your base, and obviously you don't see a value there, but if there's nothing, the invisible 1 is assumed. So we know the number of moles for our acid is 1, and the number of moles for our base is 2. Step 2, that is obviously where you're going to substitute, pick the correct formula, which we've already identified the formula we're going to use. So if I can come and create another one here. So it is number of moles of acid over number of moles of base is concentration acid, volume acid, concentration base, volume base. Remember I said this is a ratio. So centimeters cubed, I can leave it as centimeters cubed. Number of moles of the acid is 1, number of moles of the base is 2. Concentration of the acid is 0.01. Volume of the acid is 25. Concentration of the base is what we're trying to calculate. Volume of the base is 27.3. And then solve for the concentration of your base. Now, what I want you to pay attention to here is this formula. You can actually invert it prior to your substitution. However, it's not necessary to do that. So it would be 0.01 times 25 divided by 27.3, and then obviously this 2, which is divide, becomes multiply. It becomes like that. And so put that in our equation. So it's 2 times 0.01 times 25 divided by 27.3, and our value is 0.010 molar. Right. So let's just see that. 0.01 molar. Easy to understand. It's step 1. Right. This was step 2. Here's step 3. And obviously step 4 is answering of your question. This is very basic. We're going to look at exam type questions. And in the exam type questions, again, it's about identifying your variables, picking the correct formula, substituting, and then finding your answer. All right.